Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of straight lines, and this question we have been taken up from the year 2023. And if I talk about the question which is given to us here, the question tells us that alpha and beta are the orthocenter of triangle ABC, where we have been given that the vertices of A, B, and C are A is 3, minus 7, B is given to us as minus 1, 2, and C is given to us as 4, 5. So these are the three vertices given to us. We need to find the value of the expression 9 alpha minus 6 beta plus 60 is equal to what? So we have to find the value of this entire expression. And there are four options also given to us in respect to this idea. The first option being 30, second given to us is 40, the next option 25, and the last option 35. So we need to figure out which of the following four options is the correct value of this entire expression. To find the correct value of the expression, we will first need the coordinates of the orthocenter. So let's find the coordinates of orthocenter first. So if I have a triangle here, let's say this is A, B, C. A is 3, minus 7, B is minus 1, 2, and C is 4, 5. Now what I can do here is, we know that orthocenter is nothing but the intersection point of the altitudes of the triangle. So if I first find the equation of altitude which is drawn through A, altitude is nothing but perpendicular to BC here. So let's say this point is D where it is touching BC. So equation of the line altitude, for that we'll need first the slope of that line. So if I want to find slope of the line, it is perpendicular to BC. So first of all, I'll have to find the slope of BC. So if I find slope of BC here, I know I can find it by using the idea y2 minus y1 upon x2 minus x1. So change in y upon change in x. Slope of BC, if I'm finding, it's 5 minus 2 and 4 minus 1. So that gives us 3 by 5. Once I have the slope of BC, I know for two perpendicular lines, product of the slopes is minus 1. So slope of AD and slope of BC, the product of them is equal to minus 1. So if I want to find the slope of AD, it is nothing but negative reciprocal of slope of BC. So it is minus 1 upon 3 by 5, which is minus 5.3. So we get the slope of AD, that is the altitude. Once we have the slope of AD, I can just find the equation of that line altitude AD, and that is given by slope point form, where slope of AD is minus 5 by 3, and the point which is present in this, we know it is A. So A is 3, minus 7. So this is your x1, this is your y1. If I use the idea of equation of line, y minus y1 equal to m x minus x1. So y minus 7, so y plus 7 is equal to minus 5 by 3, x minus 3. So you get this 3y plus 21 is equal to minus 5x plus 15. Because of that, minus 5x goes on the other side and makes it 5x plus 3y is equal to 15 minus 21, which is minus 6. So you get the first equation of the altitude AD. Now let's find other equation also of the altitude. So if I have, let's say, another altitude passing through point C here, and that is perpendicular to AB. Let's say it's intersecting AB at point E. So if I want to find slope of line CE, first I'll find the slope of AB here. So slope of AB, if I want to find out, I can just use the idea again. Y2 minus y1, x2 minus x1. The change in y for AB, if I see, it is 2 minus 7. So 2 plus 7. that is 9. And the denominator, if I figure out x2 minus x1, so since we took y2 as 2, x2 becomes minus 1. So minus 1 minus 3, which is minus 4. So you get it, minus 9 by 4 is the slope of AB. Now if I want to find slope of CE, we know it is perpendicular to AB. So product of the slopes is minus 1 again because these are the two perpendicular lines. So slope of CE becomes negative reciprocal of AB. That is minus 1 upon minus 9 by 4, which is by 9 because minus and minus cancels. So you get slope of CE, that is the second altitude, as 4 by 9. And we know that CE also passes through point C, which is the coordinate known for C, that is 4, 5. So now for the second equation of line, if I want to find out, I know the slope 4 by 9. I also know the coordinate C 4, 5. So if I want to find equation of the altitude CE, that is given by y minus y1 equal to x, sorry, is equal to m x minus x1. So from this I get this y minus 5 is equal to 4 by 9 x minus 4. If I solve this further, I get 9y minus 45 is 4x minus 16. If I write that further, taking everything on one side, so 4x minus 9y minus 16, if I take it on the other side, because it's minus 45 plus 16, which is minus 20. So you have another equation also of the altitude. Now to find the orthocenter, we know that orthocenter is nothing but intersection of all the three altitudes. But we don't need to find all the three because I can just find the orthocenter O, that is intersection of the two altitudes also, by solving the two equations of lines simultaneously. So I don't need to find the third equation of altitude also. If I have these two equations of altitudes, one is this and the other is this, I can just solve them simultaneously and get the values of x and y. And those values of x and y are nothing but the coordinates of the orthocenter, which is O. So let's solve these two equations simultaneously. So first equation we have here is 5x plus 3y equal to minus 6. The other altitudes equation we had it was 4x minus 9y equal to minus 2. If I just solve this two, I know that to solve this two simultaneously, I need to make coefficient of 1 same. So to make the coefficient of y same, I'll multiply throughout this equation by 3. So my equation changes to 15x plus 9y equal to minus 18. And the other equation becomes 4x minus 9y equal to minus 2. If I solve this simultaneously, I'll add both of these equations, this get cancelled. This becomes 19x and minus 47. Further simplifying this idea, x becomes minus 47 by 9. So I get the x coordinate of the orthocenter. Now let's find the y coordinate also of the orthocenter. I have the first equation with me. If I put in any one of them, I get the answer. For y, I know 5 into x was minus 47 by 19 plus 3y equal to minus 6. So 3y becomes minus 6 plus 47 into 5 by 9. So minus 19 into 6, which is minus 114. 47 into 5, 235 upon 19. So y becomes, sorry, 3y becomes 121 by 19, or in this case, I get y as 121 by 19 into 3, which is 56. So I have x with me, I have y with me here. Once I get the coordinates x and y here, those are your coordinates of the orthocenter. One is minus 47 by 19 and the other is 121. So coordinates of orthocenter here in this case are given to us as alpha and beta. So we get the values of alpha and beta, that is alpha is minus 47 by 19. Beta is 121 by 56. I have these two coordinates of the orthocenter. Once I have the coordinates of orthocenter with me, I can just substitute that values of alpha and beta in the expression for which we have been asked to find the value and get the answer. That's all that. So if I write down that expression which is given to us. 9 alpha minus 6 beta plus 16. That is equal to 9 into minus 47 by 90 minus 6 into beta, which is how much? 121 by 57 plus 60. So you get this minus 47 into 9. So if I multiply 47 with 9, I get 9 7 is 63, 6 9 is 36, 6 423. So you get this minus 423 by 19 minus 121 into 6. If I multiply 6 ones are 6 and 6 12s are 72 upon 57 plus 60. Now if I want to make the denominator same here, I'll multiply both sides by 3. Once I multiply both sides by 3, I get this minus 12, 69 minus 726 upon, I get this as 57 plus 60. Now once I solve this entire expression, 726 plus 1269, if I add it out, 9 plus 6, 15, 1, 9, 9, so 1995 plus 60. So we get this entire expression as minus 1995 by 57 plus 60. If I solve this further, 57 if I divide by 1995, I get 57 threes up. That is how much? 150 and 150 and 21, 171. So you get this as 28, 285. So if I multiply 57 by 5, let's see what I get. 7 5s are 35, 3 5 5s are 25, 28. I get that same thing. So I get the answer here for the question that 1995 divided by 57 is nothing but minus 35 plus 60. So I get this entire expression's value as 60 minus 35, which is. So I get the correct answer for the question that it is 25. And if I see the option that matches here with the question is C. So C is the correct answer for the question given to us. I hope you have understood this, how to solve this type of questions which deals with the concept of orthocenter. So first we figured out the equation of the altitudes by using the idea of perpendicular lines. Once we found the slope of the altitude with one coordinate or 1 point, we use slope point form to find the equations of altitudes for AD and CE. Once we got the equations of altitudes, we just solved the two linear equations simultaneously to get the values of x and y that were nothing but the coordinates of the center, alpha and beta. Once we got the values of alpha and beta, we just put them in the expression for which we have been asked the value to find out. And once we solved this entire expression, we saw that the answer matches with option C. So C is the correct answer for the question. So I hope you have understood how to solve this type of questions. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains as well as the questions on 11th and 12th. So stay tuned for more videos to roll out. Also, do like, share and subscribe to my channel. Do share these videos with your friends also who are involved in this preparation of JEE journey. Thank you.